Hey, so this is section 2.7, proving angle pair relationships. Just note that this is live, so if anybody talks, they will be in this video for as long as it's used. So if you don't want to be a participant in this video, then at the very end, I'll take some questions and comments for you guys, so I can answer some questions. This first one here, we're going to do right angle congruence theorem. All right angles are congruent. We're going to prove this. First thing that we have is our statements and reasons. First statement, obviously, is going to be our given. So L is perpendicular to M, and L is perpendicular to N. Based off of this being perpendicular, we know that angle 1 and angle 2 are right angles. How do we know this? Well, if we are looking at what this first statement was that those two L and M are perpendicular, and L and N are perpendicular. This is the definition of perpendicular lines. From there, we can then state that angle 1 is congruent to angle 2 based off of the right angle congruence theorem. That's what makes the right angle congruence theorem so nice, is once we know they're perpendicular, and we've stated that it was because of the definition of perpendicular lines that those are right angles, then we can jump right into right angles congruence theorem. Notice how every reason, okay, literally looks at the previous step and previous statement in order to get the definitions. The chart of all the definitions and reasons that I gave you still holds fair to 2.7, and it will also hold fair to Unit 3 as well. Theorem 2.4 is the congruent supplements theorem. It says if two angles are supplementary to the same angle, then they are congruent. Theorem 2.5 is the congruent complements theorem. So that is also saying then if two angles are complementary to the same angle, or two congruent angles, then they are congruent as well. Let me take you through example number 2, which then proves congruent complements theorem. It says that we want to write a proof. It says angles 1 and angle 3 are complements. Angles 3 and angle 5 are complements. Prove angle 1 is congruent to angle 5. Let's first write our statements. And reasons columns. And then the first one here, let's write our given. Angle 1 and angle 3 complements. Angle 3 and angle 5 are complements. So what is this telling us? It's telling us that angle 1 and angle 3 are complementary angles. It's also saying that angle 3 and angle 5 are complementary angles. Notice how both of them share 3. And if you look at even closer, 1 and 5, those are vertical angles. And we know that vertical angles are congruent. So by using congruent complement theorem, we can write our last step. Angle 1 is congruent to angle 5. How is this possible? The congruent complements theorem. And look, it still uses the reason is based off of the previous given statement. Okay, the angle 1 and angle 3 are complements. They both share angle 3 and angle 5 being complements as well. So then 1 and 5 are congruent. Those two proofs were pretty short. This next one just gets a little lengthy with how we're going to word things. This is based off of the linear pair postulate. So the linear pair postulate states that if two angles form a linear pair, then they are supplementary. Given angle 5 and angle 7 are vertical angles. We need to prove then that angle 5 is congruent to angle 7. Notice how they put 6 in there. We're going to be using that with our linear pairs. I'm going to go ahead, I'm going to write my statement and reasons. Sorry. Statement 1 is always the given. Angle 5, angle 7. Vertical angles. If we are using the linear pair postulate, okay, that means that we have to define a linear pair somewhere within here. So step 2, angle 5 and angle 6 are a linear pair. And angle 7 and angle 6 are a linear pair. Linear pair, remember, means that you have two angles that are adjacent to each other that equal 180 degrees. I'm actually going to go away from the norm. I'm going to state that this is definition of linear pair. Usually it's based off of what we would see before. But in this case, because I'm trying to prove a linear pair postulate, then it is not. How do you know that these are linear pairs? Both of these angles are adjacent, which means that they're beside each other. And if you notice, this makes a straight line, so that it constitutes that both of those angle sums are 180 degrees. And that's what a linear pair is. So they're 180 degrees, which makes them a linear pair. The same goes with this as well. Let me back up here. These two would also be linear pairs, because if you're looking at this line, okay, the sum of those two with that line is 180 degrees as well. So essentially 5 and 7 are congruent, which we're going to see here using this linear pair postulate. And then I'm going to show you how to make this even simpler on the next proof that we do. So in this case, our next step, angle 5 and angle 6 are supplementary. And angle 7 and angle 6 are supplementary. Because remember what supplementary is. Supplementary is literally just a loose definition of a linear pair. Supplementary angles equal 180 degrees. So do linear pair. Supplementary angles do not have to be beside each other. Linear pairs do. So on step 3, this is our linear pair postulate. This is saying that two angles form a linear pair, then they are supplementary angles. Now, step 4, okay, is going to be our congruent supplements theorem that I believe we talked about in 2.6. So step 4 here, angle 5 is congruent to angle 7. This is the congruent supplements theorem. I'm sorry, we just talked about actually in 2.7 because they're supplementary angles. Now here's the deal. You know how I've always said to you sometimes there's more than one way to simplify a proof? This is a perfect example because the next theorem is the vertical angles congruence theorem. So I'm going to show you vertical angles. We all know vertical angles are congruent. Okay. I'm going to show you how to do this proof, and then I'm going to jump back to that last one. I'm going to show you how we could have done it even quicker, even more simple, but we wouldn't have used linear pair postulate. So in this case, vertical angles are congruent. I'm going to write my givens here. Statements. Reasons. Angle 2 is congruent to angle 3. That's going to be given. If we're looking at this as well, what we're trying to do is we're trying to prove that angle 3 is congruent to angle 6. Angle 6 and angle 3. What we know is angle 2 right now is congruent to angle 3. Look at the placement of 2 and look at the placement of 6. Angle 2 is also congruent to angle 6. This is based off of the vertical angles congruence theorem, which is just a fancy way of saying that vertical angles are congruent. So then, in order to say that angle 3 is congruent to angle 6, we use the transitive property. Now take a look. Wouldn't that have been really nice to know in that last example 3? Because check it out. What are we trying to do? It says angle 5 and angle 7 are vertical angles. Angle 5 is congruent to angle 7. This literally could have been done in 2 steps. Angle 5 and angle 7 are vertical angles. Given. Angle 5 is congruent to angle 7. Vertical angles congruence theorem. Okay. So by knowing these different types of theorems, we can actually shorten our proofs to be a little bit easier. I've got one more example for you here, and then a multiple choice question. This is more of what you're going to kind of see where your statements are filled in, and then you are choosing your justifications if you were to take a graded assignment. Given angle 1 is congruent to angle 5, we need to prove that angle 1 is supplementary to angle 4. So the first step here, it says angle 1 is congruent to angle 5. That's our given. Then we go to measure of angle 1 is equal to the measure of angle 5. Definition of congruent angles. Remember, if we move from equality to congruency or congruency to equality, we need to say definition of congruent and then whatever we're working with. In this case, it's angles. Angle 4 and angle 5 are a linear pair. We can say that that is because of the definition of a linear pair. And then once we know that those are a linear pair, angle 4 and angle 5 are supplementary. That would be our linear pair postulate. The linear pair postulate is only used after you've stated, 1, that 2 angles are a linear pair, and 2, that those same angles are supplementary. So if you can state those 2 things, one of your justifications is going to be that linear pair postulate. Yeah. No. So there's two types of supplementary angles. There's either supplementary angles that aren't beside each other. So supplementary angles that are not beside each other. Those are literally just called supplementary angles. Or there's supplementary angles. I guess those would be complementary angles, the way I'm drawing them. Let me draw them a little bit better. Boom, boom. Okay, there's one angle. Then two. Another. They're not attached. The other type of angles that we have look like this. This is a linear pair. This is just supplementary. Either way, they're both supplementary. It's kind of like along the lines. It's like not every square is a rectangle, but not every rectangle is a square. I think. Measure of angle 4 plus the measure of angle 5 is 180. Is equal to 180. Definition of supplementary angles. And then now that we know this, if you take a look at here, this step, and then this, that is how we end up getting the measure of angle 1 in here. So that's substitution. And then angle 1 is supplementary to angle 4. Again, that's definition of supplementary angles. And we use that based off of the fact that we were able to plug that angle 1 in for where angle 5 was located. Last example that I have, and then like I said, I'm going to shut this off since this is live, and you guys will scroll back through. You can ask me any questions you want to. Which equation can be used to find the value of x? Notice that both of these combined equal 90 degrees. So this is automatically out. This would also be out as well. And this is equal to 128? No. So it would have to be letter A.